So this is a waves question for grade 11 physics taken from our problem book. It's number 20. We'll read it through here and I'll show you how to get it done. Two people are fishing from small boats located 30 meters apart. Waves pass through the water. Each person's boat bobs up and down 15 times in 1 minute. At a time when one boat is on a crest, the other is in a trough. There is one crest between the two boats. What is the speed of the waves? It's a longly worded problem, and so the best thing to do is reread it, write down information as you go, do a diagram. In fact, that would be the first thing that you would do based on the description starting at a time here. So at a time when one boat is on a crest, the other is in a trough, and one crest between them. So draw your water waves, kind of exaggerated, doesn't really matter. One boat is on a crest, there's our boat, one of the better boats I've drawn. Now one is in a trough, but there's one crest behind them, so the other boat has to be down here somewhere. Now the water waves are exaggerated, so the distance between the boats is just a straight line distance. That's 30 meters. Okay. So I visualized it. I don't even need the rest of the waves. Don't have to erase them, but just to clear it up. So one's on a crest, one's in a trough, one crest between them, 30 meters apart. Each person's boat bobs up and down 15 times in 1 minute. That is the number of waves per unit time, so that's a frequency. So the frequency is number of waves per unit time. So again, we always work in seconds, so I'm going to change that 1 minute to 60 seconds. So it's 15 waves in 60 seconds. So the frequency is 0.25 hertz, or a quarter of a wave per second. Now to get wave speed, we're missing something. When we're talking about waves, wave speed is frequency times wavelength, or wavelength divided by the period, but either way, we are missing wavelength. Got to figure that out first. And this is where your diagram comes in. Label correctly, and if you draw it correctly, you can get wavelength. If you didn't draw it correctly, you're not going to get this problem correct. So count how many waves there are from one boat to the other. So here I've got one full wave from crest to crest. That's one full wave. As you go from crest to trough, that's another half a wave. So in that 30 meters, there is 1.5 wavelengths, 1.5 waves. So now we have a relationship to figure out my wavelength. Right, so to figure out my wavelength, I know that 30 meters of distance is 1.5 waves. Now this is a very important thing that we did. We're going to do this a lot in this unit, is count waves and know the distance between those 2 points and figure out the wavelength. So divide 30 by 1.5, and that should give you a value of 20 meters is wavelength. So we have wavelength, we have frequency, quickly figure out speed. Frequency 0.25. Wavelength is 20. So it's essentially 20 divided by 4, or a quarter of 20. That is 5 meters per second. So once again, key for this problem is to draw the diagram, to know the distance, the number of waves contained in 30 meters, and that the frequency is the number of waves that pass by per unit time. Work carefully through your math, and you get a speed of 5 meters per second.